Recording. So, hi everybody. I have no idea what day it is. This is in module 3. We're on singly linked lists. Go ahead and copy this and paste it into your IDE of choice. And you probably want to scroll up and have this on screen. I'm going to draw on my visualizer camera and do it from there too, but something that nicely have available. Sure. My shit must have shut off earlier. So we're on lecture day 7. Just want to remind you, next week is a day off. Looking at singly linked lists. That's not the problem. I keep doing that. I try to say that's what I want to open, and it's not a fucking project. I gotta hit create new. I do this every time I open this. Type it in the name of what I want to name the new file and the open recent project. Now I gotta fucking copy and paste this shit. You'd think I'd learn, but nope, that's just fucking apparently not in my game. All right. MF. I re-grabbed something else to copy and I forgot. I had a bunch of shit waiting. There you go. All right, up to the top. Let's throw in some more shit. This is CSCI 02, lecture day 7. And it says singly linked lists. And 2024. You guys get to spend Valentine's Day with me. Isn't that special? Do not bring those fucking nasty ass candied hearts that fucking kids like to bring teachers. I like candy. I don't like those little. Wow. Why are we trying to bribe the teacher for chocolate? That's ridiculous. I didn't say I don't want chocolate, but I can't offer extra credit for it.
You never asked for that. That's an assumption.
No, they said extra credit over there. You're just playing it subtle.
I just thought it was a really good idea.
Well, see, Max, don't sit next to him. That's true. Because you're all the way against the wall, unless you walk past him to sit in the corner. That seems weird. All right. So what do we got here? We got a class here. We got a class called node. And right now it's storing a string called item. And we've got a node pointer. And it says next pointer. So it's designed to point to something else. So like a basic node block looks like this. Where's the top of my page? So we got whatever the value is stored right here. And we got a pointer right there. And this is a node. Okay. That's all it is. And right now we've decided this is a string. And of course, node pointer. All right. So that's what these look like. We've got some constructors. of wide variety, a default with nothing in it, one with the string, and then one with the string and a pointer to the next node. And we have some accessor methods with set item, get item, set next pointer, and get next pointer. And then we've got an external function, not a method, for printing the string list. And apparently it takes in someone, whoever wrote this, made a very long but well-named variable. Beginning node pointer tells me exactly what I should be passing into this, the first one. So it looks like these are designed to, like fucking Lego blocks, connect. We have the lead one, or the head pointer, and it points to another one. And it points to another one. And eventually this value, this is going to be like a null pointer when it gets to the end. Because you don't want a floating pointer that does nothing. And I'm betting when we go down and look at the constructors for this, the pointers are put as null, except for the one that takes it in. Like only this bottom one takes in a pointer. I'm betting these have it already set to null pointer. All right, so we get down to the main. We have a node pointer creating. We're doing this at runtime. We're creating one called the head pointer, and immediately we want to set it to a null pointer. Always have it as a null pointer to start off with, in case you don't do something with it. It's good practice. These two are different. One is an actual address and one's an actual node. And when they're done, this is at runtime. And then we've got another node pointer saying the current node pointer equals null pointer. And current node pointer, this is an iterator. We're going to use this and read to like, you'll see. So we're gonna hard code a linked list. So that's what this chain of shit is. Over here, when we do a bunch of links of objects like this, this is called a linked list. It's called singly linked list because it goes one direction. The arrows point forward. So if you start at the head of the chain, to get to anywhere in the middle, you got to cycle through them, which is actually the computer does relatively quickly. So for current node pointer, then we're like, this is a pointer. Recall, this is a pointer. We make it a new pointer to a node that has married. And since we're calling on these, let's go look at the constructors real quick. Right there. So this has got set item, the value to nothing. And the string is a null pointer. And then this one does argument and null pointer, which makes sense. And then this one actually assigns the argument and the argument pointer. And the accessor methods work as we would expect. Taking the argument, set it equal to the variable. And same thing with this. All right, back up to the code. So right now, what we've done, let's get this, see if I can shrink it down a little bit. Yeah. That helps get it all on the screen relatively easy. All right, so let's track what's going on. So node pointer, the head pointer pointed to, we'll call this null PTR up here. And it starts off pointing at that. And so does current node PTR. They're both pointed there. And then all of a sudden we cross this off and we get down to line 43. And this now points to a new node that has Mary in it. And since there's nothing assigned, this points to null pointer. So I'm just, rather than writing null pointer a bunch of times, I'm going to use it as one spot. So that's line 43. And we've got the head of our list. This is the head of our list. And so 44 goes, okay, let's make that our head. So 44 crosses that off and says, okay, this starts here. This you only usually want to do once. Unless for some reason, when you've adapted and modified your way to do linked list, you want to create something, you want to insert something before the rest of the list and make a new one. Other than that, head pointer never changes. We don't want to fuck with that, because if we do, remember, this is a pointer to an address. If we fuck with head pointer, we lose the beginning of the list. That makes sense? This is our only fucking way. It's like the numbers on the fucking mailbox. They're the only way of knowing who the fuck's there. It's a respawn point. That's a fucking great analogy. It's a respawn point. You don't want that fucking being camped by monsters. Leave it alone. All right, so we're over here. Then we go 946, populate second node. Okay, this says current node pointer says do set next pointer as new node Bill. Well, this, as a reminder, this is value. And this is set next pointer. Or I'm sorry, that's next pointer. This is next PTR. So it says we're gonna cancel this null pointer shit. And we're gonna make a new node instead. And we're pointing it to Bill. And Bill starts off with a null pointer. And that's our current node. So that kills this blue shit. No, it doesn't. Current node pointer is still set to there. That's still there. Oh, wait. Wait for it. Very next line. There it gets reassigned. So we had to make the new node. And then jump to new node. So line 47 made this. So this is crafting this was 47. And then reassigning the current node pointer to this was line 48. Now head pointer is pointing at Mary and current node pointer is pointing at Bill. Everyone with me? And you'll see this forms a cycle. It's actually a relatively simple cycle. We make a new pointer. This points to James. And it has a null pointer. And we kill that pointer. And that's all we killed there. And then line 52 was make that the new one. So that kills that one. So the current node pointer is always pointing at the most recent one you've made. Head pointer's sticking with the first one. If we lose that pointer, we lose everything at the beginning of the list. When we have a doubly linked list and we're going both directions, as long as we got a pointer to something, we can cycle through and get to where we want to go. It is, but it takes more coding. But we're going to do that. If not Wednesday, next Wednesday.
Because like something could get messed up with that. Like, let's say the first node gets corrupted, they lose your entire.
Right. Right. Well, if that first node gets corrupted and you're not in the linked list already, or like accessing the data, it's all lost, because without it, that's the only pointer we start with,
Right.
as you'll see. Although we could make our linked list do something different. And then we've got the print single linked list. It takes in the head pointer. Oh, we got an Aubrey one here too. So this does Aubrey. And it starts off as null pointer, but then current node pointer points to this, and that list to null pointer goes down. And right now that's pointed to null pointer now. So Aubrey is the end of our chain.
I noticed that it's a similar logic to the accessing methods. So you have to set and get. So like, let's say you wanted to get, I don't know, information that you currently don't have. You would set it, and then you would use a function to get it. In this way, we're going from node to node, but in order to get from node to node, we need to set the point and then actually move the point there, and the actual pointer from the node.
If that works for you, is like for me, in my head, we're fucking building a bridge and we're laying this shit down and stepping on it. We fucking make sure it's all connected, then we lay the next piece down and step on it.
Because if one piece falls off, the entire bridge is gonna.
Yeah, if one piece, if the fucking head pointer that's connected to the ground falls, bridge is fucking gone. And obviously bridges don't float in the air, but this kind of fucking bridge does. This is like the Iceman, fucking laying out ice tracks as he goes ahead of himself. That's kind of like what this is doing. What? A frozen is another choice for it. Oh. All right. So we gotta do some memory management when we're done. So what does this do? So memory management part. Starts on line 60. And so what it does is it takes current next node or next pointer and actually points it at the head. So now the only thing we're pointing at is at the head of the chain, the first link. And it assigns, so let's do this. I'll only do a couple. So both of them are pointed here. That's what line 61 does. Then line 62 says head pointer is equal to head pointer's get next pointer. So like, what's my next step on the bridge? Or what's my next link? Head gets assigned here and that goes away. Maybe I'll use green for that cancel. Green cancels out that, red pointed to the next one. And then 63 says, all right, now that we've got something linked to this, 63 says, fuck that guy. Mary gets iced. And then we go to 65. 65, all right, so current next pointers pointing at nothing. Hopefully in the delete current node pointer, in our, we don't have a deconstructor there, so it's just sitting there loose. We immediately assign current next pointer over to the same thing that head's pointing at. And then head pointer, can't cancel that shit out. Head pointer says, okay, we're gonna point at Mary. And that's line 66. Jump to the next one in the chain. And 67 ices Bill. Bye, Bill. And this keeps going until we've gotten rid of everyone. And finally, it finishes off with current node pointer equals head node pointer. All right, so on line 73, this is actually worth showing. So I'm gonna do Aubrey down here. Aubrey has null pointer as her next BTR. Okay, so when we get to line 73, line 73 has them both pointed to here, and it's the last one left. Line 74 says head pointer is going to point to the next pointer, but the next pointer for 74, Aubrey, is the null pointer. And then we delete 75 is take care of Aubrey. And 77 is let's point current node pointer at the same spot head node pointer is at. So now they're both pointing at a null pointer. So we've got two pointers just sitting there floating. Okay. But the list is gone. Let's see what happens when we run. Really? Are you gonna say my fucking file name is too long? Exceeds the max path, you motherfucker. This is the worst fucking. Does VS Code do this shit? Does it have a path length that's shorter than any other thing? Maybe I'll download VS Code over this 4-day weekend and check it out there. Fuck Mac. Lecture day. I think I have spring 2024 before that. Day 7. Linked list. Hey. Do I have all of it? Yes, it does. It has my title on it. Okay. So let me close the other super long one. Just fucking tearing up fucking memory in my computer. All right, so Mary, Bill, James, and Andre is done. Looks like it makes the list nice and pretty. And then apparently when we empty the list, it says list empty. It is handy. It's pretty handy. So that must be in here. It is. So their print function takes in the node pointer. It immediately makes a new temporary node pointer. That's good. So we never lose the beginning node pointer. You're gonna find when we want to modify shit, like build functions and methods for a class for lists in a second. This little whole check to see if the temp node pointer is a null pointer is a great way of finding out, is this shit empty to start with? Because if it is, difference is going down. Adding to an existing list takes different steps than starting the list. So that's what this kind of does. When we do that here, it's just checking to see if the list is empty, and then it cycles through it. While temp next node or temp node, it gets the next pointer and makes sure it's not the null pointer. Okay, if the next one's not null, we'll grab the item from the next one, we'll print it out, and then we jump to the next node. And it keeps jumping until it goes, okay, the next node has a null pointer at its end. So it's the last fucking item. That's what this does. So this little while loop will jump or stop at the node before the last, because it's checking get next pointers, null pointer. No, it isn't. It'll stop at the last node. Okay. And this one prints it out each cycle. This line prints out each one. And then we jump to the next, but after we've jumped to the final loop, after we have jumped to the final node, this doesn't print it, because the print is in the while loop. So this line takes care of that gap and prints the final item. Camera wise, so it starts off here. It's not a no, next pointer is not a null pointer. It prints Mary and jumps to Bill. Then it resets the while loop. The next pointer is not a null pointer, so it prints Bill and jumps to James. And it checks to see if James's next pointer is the null pointer. It isn't, so it prints James and jumps to Aubrey. Gets to Aubrey, checks to see if Aubrey's next pointer is a null pointer. It is. The while loop ends. Aubrey hasn't been printed yet. And so line 101 catches Aubrey. That makes sense? There's a lot of gymnastics here. And you see, like this we were just going one direction, and we're constantly having to point out, cross out arrows as we're going, because the addresses where they're pointing change. Any questions on that so far?
Kind of looks like a linear search, right? You get cycles through and so on.
Yeah. In fact, that's one way of doing it. When you want to do a search it, you can search through one item at a time. A long enough list, that gets tedious, and that's where we get, what do we call those fancy little tables that we like to, why you gotta ruin it now? It's making Juan do his work. I know, you're just sitting there looking bored. I wanted to include you. All right, so I see all this, and I gotta say, fuck hard coding. Like, right? Are you with me? So let's remember that node. Let me put it up here. I'll put it right after it. Node, oops. Node has a string item and a node pointer. Next pointer. And now I can shrink that so it doesn't take up so much bucket space on the screen. I don't need the details. I just need to know what's in it. We'll keep that C-type function there. Let's make a new class. Our linked list. So it looks like the list doesn't start until we get a head pointer. So maybe our first, our item in here will be a node pointer called head. Anything else we should have? Because remember, head will have item and next PTR. What?
You could have like Carol be like this and go through this.
We could. maybe we need to make some, let's make a constructor for this. Let's call this private. And we'll come down and make these public. So we have our linked list. And we'll have a blank one. And then we'll have our linked list that takes in head. And we'll probably want some set methods. So our accessor methods. We'll do a set head. And that has no return, but it takes in a node pointer. Arc head. And then we want to return a node pointer. And we'll do get head. And we're eventually going to want, I'm going to comment it out for now, but we're going to want to do our destructor method here. So our destructor. Do this. Print methods. Okay, so let's grab this shit and come down below our main and start making them. So they all got to start with the name of the class, followed by the scope resolution operator. Why is it saying I'm trying to redefine it outside the class? Think that's it? Yep. Quit doing that. I hate that. Yeah, I think I'm doing the same thing again. So our set head will be head equals arg head, right? And our get head will be return head. So our linked list, this doesn't take anything in, so head will equal blank right now. And no, it won't. Head will equal null pointer. Fuck. Scroll off screen. Here we have, what do we have? Arg head. Arg head is a node pointer. So head equals arg head. What? All right. That's why I did them first. Fucking scrub. And pause, make sure everyone gets to this. It's funny that you're working on a rocket with Davis, because I know Davis wants to do like, he wants to make like bionic arms.
Yeah, we're also gonna work on that too, because I'm engineering. So.
Okay. I remember you talking about making a fucking text-based story. And the next thing I know, you're like, neither of them are related to rockets whatsoever. You're like, we're gonna make a rocket. Okay. Have a good time.
We wanted to set our goals.
Right. So implementations for our linked list. All right, let's come up here now that we have it. Let's implement it. So what do we have here? We still kind of want to make a node pointer because that's what this takes. Our linked list takes a node pointer. So this part still needs to be done. So number 2, I'm going to change this to say, since I'm going to copy and paste, if you want to see the hard coded, see the pre-existing lecture notes. We are switching to a class. All right. So I'm gonna fucking just delete the rest of this shit. And I'm gonna delete the memory management. But I'm gonna leave the fact in there that I need to do it in there as a reminder that I should clean my shit up when I'm done. Okay, so here, this was all the starting stuff. Let's come back and look at our shit again. We are doing A, B, C, D. Let's do this one right here. Oop. So we're gonna do A, B. DR is box. And that's where we got to start. So step 1 is make the head pointer. Step 1 is not done yet. So right now, this says head pointer is null pointer, my node, and then current node pointer. They're both null. And then we're going to make head pointer equal new node. And we wanted it to be AB like that. What the fuck? What? So that makes that, and now we got to use our linked list. So we're going to do our linked list, my list, and we're going to take in head pointer. And I'm just gonna fucking run it and see if we've got AB on the list. AB, bam, boom. All right, so back over to our camera. That's what we did here. So we made head pointer actually point to a new one called AB. And right now it's got a null pointer. I'll list it as an X for now. And we have gone and said our linked list points there. So they're both pointed there right now. OLL is our linked list. Because that's going to take a while to write every fucking time. All right, you guys with me? Let's shrink that down a little bit so we can see both. Okay, so we did that and we want to add a new node. Maybe this should be part of the class. This is a clear indicator that we're missing something. Right? We got to do this a lot and we didn't want to hard code it. So clearly maybe we need to add more to our class. Let's go back up to our class and do add node. So add node is going to be a void. Add next node. Add tail node. That way we know we're adding it at the end. This is very specific. Our PTR. What? I should do set tail node and get tail node, right? Why am I doing set tail node and get tail node? Why don't we do just set tail and get tail? We had set head and get head. All right, let's come down and add those below. It keeps doing it. It fucking kicks it to the next line. Oh, I hope there's a way to change the settings in the IDE that it doesn't do that. Fucking don't like that. And it doesn't do it until I fucking hit run. It's a sneaky son of a bitch. All right. So. What? Yes. We need our scoping, right? I put that next to the nodes. Fuck all that. Let's take that up and put it next to our linked list. Okay, so we got to start off. If someone tried to use this to set the head, we need it to compensate for that. So we're going to start off with node pointer temp PTR equals arg PTR. That's always good mojo. And then we're going to check to make sure temp pointer does not equal null pointer. Well, maybe we'll say if it does equal. We'll see out. this starts a new list. And then maybe we do set head with our temp pointer. That's what's wrong. I capitalized the P. There we go. So this accommodates empty lists. All right, so I don't want to just say next pointer is the new one. We got to pretend like this list is really fucking long. So then we need to cycle through a long list. Get to the end. So while temp PTR get next PTR does not equal null pointer. So what this is doing is I fucking capitalized the P again. What this is doing is going, okay, where we're at, are we at the end? If we aren't at the end, the next pointer is not going to be the null pointer. So if the next pointer is not the null pointer, we need to jump to the next pointer. So temp PTR equals temp PTR. Oop.
On that first initial if statement, if that condition is true, then we're going to do anything after that. Right?
You're right. We should do a return. That'll break us out of it. That would have shown up as a problem as soon as I tried to run it on an empty list. Good call. This breaks us out if the list was empty, so it doesn't try to add the node twice. So while the next pointer is not null, so until I get to the spot where the next pointer is null, I got to keep stepping forward. This should get us to that point. Then when we get to this point, we need to what? Temp PTR set next PTR with temp PTR or with no. This is not what I want to do. Temp pointer equals head pointer. There we go. That makes more sense. That makes much more sense. So we immediately grab the head and go, okay, is the head empty? If the head's empty, fucking make it the head. If the head's not empty, jump to the last node on the chain. What? You're right. Good call. All right, so that all said it. this will jump us to the end. Temp PTR, set next BTR to arc BTR. Right? Is that it? Is that all we need? I'm assuming they did that when it was set up. Temp PTR equals get next PTR. And let's make sure that is null PTR. Here? Don't we have that in the next? I think that's already done. No, it's not. But it's taking in an arc pointer. And the default arc pointer should have its address listed. So when this is created using these. And all of these either have no pointer or a pointer. So there's no way this is bypassing having a pointer at the end. So I don't think what I did up here was necessary. This part wasn't necessary. Because null pointer or the node class took care of it. Note, this is very important. We have that node class and we have our linked list class. And our linked list class is filled with fucking node pointers, but it is not inheriting them. It's fucking using them. They're tools. They're bricks for its job. They're links in its chain. But we are not inheriting anything off of it. Okay? All right. I think we got this set up. Let's take a look at it on paper where we're at right now. Because we want to add the next one. So we're going to have to create a node pointer. So we'll have a temp one that points to CD and has an X. That'll be this one. And we need to make sure that this is doing that. So we're passing in our temp pointer to here. And maybe I shouldn't use temp when I've got temp right here. Current. Let's call this current. So our current pointer is CD. So we go into our thing and temp pointer gets the head. Head is AB. Temp pointer is not null, so it skips this. It gets us this. It says while temp pointer dot get next does not equal null. This is the get next. The X is the get next. So it is null. So it's going to skip this while loop. And it's going to go straight to adding this. So it's going to, what this does is replaces that X with a pointer. Which means I have to do the current with the CD. That's what I need to do in the main. So current node pointer is new node CD. And then we're gonna do my list dot set tail. equals current node pointer. Let's see if it runs for 2. Nope. So what is off here? Our link must return some. Oh, I don't have a return. I didn't do this. Fucking scrub. I don't even know why you listen to me, you guys. Get tail should do the same thing as this. So I'm gonna just copy this shit. And we're gonna edit it. So we don't need the C out. And we don't need that. We're just gonna return temp pointer. Otherwise, temp pointer is going to jump to the end. And this was jump to the end. So when we get to here we should return temp pointer. I don't even know that I need the fucking first thing. Yeah, we do, because if there's no node, it's not going to have a get next pointer. So this needs to break out here. So this is the empty case. I already said that. We have to have that, because otherwise, if we don't do this and we try to run it on an empty list, the temp pointer is a null pointer, so it doesn't have a get next pointer. It's not pointing at a node, so it doesn't have a get next pointer. And the computer's going to freak out on 123 if we start off with an empty list. But in both cases, temp pointer is going to get us to the end. A, B, C, D. Okay. So will this continue to work if I just copy paste and put EF and GH? And IJ. I think that's what everything was on that list. We can always look at the code again, make sure. So set tail, we're here. Now we're wanting to add, current is no longer pointing to that. Current is pointing to EF. So temp pointer is not null. Skips that. It goes while temp pointer. Every time it starts out at the top. While temp pointer, get next pointer does not equal null pointer. It doesn't. We're going to say temp pointer equals the new pointer. So that takes us there. So temp pointer is now pointing at CD, and CD's next pointer is a null pointer. So it stops there and it says set next pointer to EF. This looks like this should work. It looks like we set it up right. Just copying and pasting after we got that going. Regardless. Okay, we still need to do a destructor. Can we streamline this? Can I say my list dot set tail new node KL? Can I make this a one-line event? Let's check. I think so. Why have all this when we can just make it in one line?
Just have it cycle through by itself.
Bam. So we can expedite all this. We can trim all that shit down. Lines for CD through IJ can be rewritten. A single line for each, like the KL line below. Now, I don't think this following thing is standard on linked lists, but I think it's fucking stupid to not have it. Why do we just have a fucking head node? Wouldn't this be a lot easier if we had a fucking tail node saved too? We wouldn't have to do adding a new node to the end would be simply as get tail and then add node, right? We wouldn't have to do all this cycle shit. So we only got 10 minutes left. Maybe let's make a list of shit we want to do for the next class. We're gonna build on this. I will do our destructor, but so for next class, let's do this piece of shit thing right there. For next class, let's make a tail PTR, not just a head pointer. And then we can look at other methods before we jump to doubly linked. Like maybe add in the middle. Delete from the middle. Delete from somewhere. Delete from somewhere without killing the whole list. So these seems like some things we need to address next time. But with 10 minutes left, let's get at least our memory management done. Let everybody finish writing this. If you guys think of some other things we want to try next week, let me know. Or not next week, on Wednesday. Where's Doster? You got such a glowing review about being such a great student, attending class, asking questions. Do you fucking see him? He's not even, is he watching it live? He's not even watching it live. Call him bullshit on Blakely's letter. All right. No one looks like they're still typing. So let's come down and do our linked list destructor. This looks weird. Looks weird having the tilde in between these two things. So we need to delete the nodes and the list at the end. So what we want to do is we'll get head. Let's make a node pointer. Temp. If, and we'll set that equal to get head. If temp equals null pointer, it's already empty. There's no list to delete. Scrub. Hit return. That's the easy case. So the hard case is, okay, so I'm gonna actually want 2 pointers. Think. Oh, I don't want temp again, current. Okay, so we need to say while temp does not equal null pointer, just kind of like we did in the other ones. So we're gonna have one of them jump to the other, the next pointer. Then, so current PTR equals temp dot get next. And then we're gonna say delete temp. Or better yet, actually, I don't know that I need current pointer. We're gonna do set head pointer. Let's do that. Set head to temp get dot next. There we go. I don't think I need current. Wait. Yeah, I do. No, I don't. Let's comment that out for a second. So if we're not at the null pointer, what is going on here? So we're here. We're at AB. Head's here. It starts off here. Set head and temp's pointed there as well. And so we're going to say set head to temp's get next pointer is going to change it to there. So temp is now pointed at AB and head is pointed at temp or at CD. And when we say delete temp, this does that. And we want to have it like we did before where temp and head were pointed at the same thing. So we could repeat this cycle. So maybe I need to do temp equals get head. So if I do temp equals get head, that gets rid of that points there. And then that's the end of the while loop and it goes, okay, next pointer is not null. So we're going to do it again. Temp is going to get set. No, head is going to get set there. CD is going to get iced. And then temp is going to point to where the head pointer is. And now this isn't what we want. I want temp dot get next. That's gotta be the criteria. So now temp and header here. Temps next is null pointer. So it doesn't do this shit and we still have EF. So we still have EF and both things are pointed at it. So what we're gonna do is we're gonna say delete temp. And then we're gonna say temp equals null pointer. Set head equals null pointer. So that makes all the pointers that we have already in the system, at least null pointers.
Right.
And then when it's done, it will delete the list itself.
As soon as you're done with that.
As soon as we're done with this thing. Do I need a return? I don't need a return. That should work. MF. Line 149. I did not. Good call. Maybe we should add a little C out at the end that says list is gone. What do you think? This was our linked list, so C out. List is empty. We could even add a line of what we're deleting. Temp dot get item. Didn't delete KL. Oh, I didn't add that at the end. That should do it. So this one, this set outside the while loop terminates the last node. And now they're all deleted. That was actually, I don't know, the C out helped. I didn't add anything to it. But if I had had the C out the whole time and didn't do this one, it would have told us we missed one. Any questions? It's 6 o'clock. You are all free to stick around and make Juan work for his money, or free to go and do something else. Peace.